welcome to an algebra tutorial video working our way through linear equations. Specifically in this video, we'll be learning how to write point-slope equations in point-slope form, given just all we have is 2 points. So here we go, we got the points 14, 80, and then we got the point 29, 77. So I'm going to go and label a couple things here. We have 1 point, so I'm going to label the x value and the y value, specific x1 and y1 for that first point. But then I also have a second point, so I'm going to label that x2 and y2, the x and y value of the second point. And let's talk about, we want to write it into point-slope form, so we need to know, well, what is point-slope form? That's y minus y1 is equal to m times x minus x1. Now, hopefully you've been watching this series, but you know that x1 and y1 are specific x and y value. So we have even labeled here x1 and y1, so we could use 14 for x1 and 80 for y1. But I could also use my other point as well, x2 and y2. These are also a specific x and y value. So I know x1 and y1, but what makes this problem a little bit different is I don't know the slope. I need to figure out what is my value for m, the slope. So we got to go back and actually remember, how do we find the slope of a line given 2 points? So we also need my slope formula to find the slope, which is m. We find out, well, how much change happened in my y values. We divide that by how much change happens in the x values. It's a rate. It's comparing the change between both my variables and dividing them to get a rate. So what we're going to do here is we're going to take my 2 points. We're going to first find the slope, given the slope formula. Then we're going to go back into point-slope form and substitute our values for slope and our specific x1 and y values to get an actual point-slope form equation. Okay, so to find the slope, I need to subtract my y values. So I'm going to take y2 minus y1. So substituting things in, we got 77 minus 80. And then on the bottom of my slope, I need to subtract how much change happened in x. So we got 29 minus 14. All right, that's going to give me my value for my slope. If I simplify those down, 77 minus 80 is going to be negative 3. 29 minus 14 is going to be 15. I can simplify that fraction down into negative 1/5. So my slope is negative 1/5. I go over 5 units for x, I decrease by 1 for my y values. It's a decreasing slope. All right, now let's pick a specific value and let's write ourselves a point-slope form equation. Just to be a little bit fun, I'm going to use this big value. Again, I could use any point, but I'm going to use 29 for my x value and 77 for my y value. And there's my slope, and I'm going to write a point-slope form equation. So y minus 77, that's my specific y value, is equal to my slope m, so negative 1/5, times x minus my specific x value, 29. And there we go. So again, what do? We found the slope. Every line has to have a slope, so we found out, well, what change is happening in this line. We got negative 1/5, and we put that in for m. And then not only do I need to know the slope, I need to know at least 1 point to fix my line through that point. And so we used my second point right there, the 29, 77. I could have used the other point, and that would also give me an equation. It would look different, but if I use the other point, I'd have y minus 80 equals negative 1/5 times x minus 14. So there's 2 different point-slope form equations, which is great. They'll both simplify down to be the same thing. If I both turn them into slope-intercept form, I'll get the exact same equation. But there you go. There's an example of writing a point-slope equation if all we know is 2 points.